review of the mid-module review. Some of this I already did in class, so I'm just talking over it, and then I will go over the last bit more in depth because that is review and stuff we haven't done for quite a while. So at the beginning it said it has this number line, and you have to plot and label all of the values on the number line. At the end of this description it says, if 0 represents the previous average daily attendance. So all of these days up here are saying 120 people more, 40 people extra, 40 people less than average. So it tells us what they're referring to at the end when it says 0 is the previous daily average attendance. So first I made my number line down here and I labeled it down here. And you can see how I did move the 0. It's not quite in the middle, but it's a little bit over to the left. That way I could count by 20s up to 100. So you can do that if you need. So I counted up by 20s, down by 20s. So I picked 20 as my scale on the number line. And then I plotted and labeled all of the values. So you need the dots, like you're plotting them, but you also need to label them because there's multiples. So if you don't give them labels, then you don't know which one's which. So it said in 1 week, they had 120 people over average on Monday. So over average would be more, right? So positive. So Monday's 120 more. 40 extra people on Tuesday, so positive 40. 40 people less than average on Wednesday, so negative 40. The average number of people on Thursday, so that would be 0. And then 50 people less than average on Friday. So right here. Remember, 50 would be between 40 and between negative 40 and negative 60. So it's here, not here. And yeah, there you go. Which day had the highest? Which had the lowest attendance? Monday has the highest because it's farthest to the right. It's the greatest. And Friday had the least attendance because it is farthest to the left. And 2 days attendance both had a difference of 40 people in comparison to the average. What's the difference about those 2 days? So both Tuesday and Wednesday, they both have a difference in comparison to the average of 40, or they both have an absolute value or a magnitude of 40, right? They're 40 away. But Tuesday was 40 more, and Wednesday is 40 less. So one's positive, one's negative. This question was, Yvonne and Doug are testing 5 different mugs, and they put them in the freezer to see which ones keep the mug the warmest the longest. So after hours in the freezer, this was the temperature of the coffee in each mug. And Doug wrote an inequality to sort them this way, and Yvonne wrote this inequality, and so they're a little bit different, and it says, is either person correct? And Yvonne is correct because he has negative 1.2 as greater than negative 2.3. So this, what I circled, is the only difference in their inequalities. And you can see how Doug says negative 1.2, negative 2.3, 2.7. So he's like putting them in order based off of their absolute value. But it's just from least to greatest. So on a number line, right, you would have 0, and you'd have negative 1.2, and then farther to the left, you would have negative 2.3. It'd be farther away from 0 to the left. So negative 1.2 should be greater when we're using the inequality symbol. It should be greater than 2.3. So if you look right here, Yvonne's is correct and Doug's is flip-flopped. If your goal was to choose the mug that kept the coffee the warmest, what would you choose? So this is a trick question. It would be B, because when you just look at the temperatures, this is the greatest temperature, 15.2. Okay. So now we have Ruth, the park ranger. She's been tasked with collecting elevation data surrounding a lake. And so here's a table with some different samples and different elevations. And there was actually a mistake in this problem, and I told my class to, if you're in someone else's class, I told my class to try and find the mistake themselves. And it said, put them in order from greatest to least. So if you did just put them in order from greatest to least, then you would have, like how we very first started, right? You'd be going from right to the left on a number line. So 238 is most to the right, and then as you travel going left on a number line, you'd hit 126, 77, -5, and then -398. And if you're putting inequality symbols in here, right, if you're just focusing on these two numbers, your inequality symbol would have to go this way because 238 is greater than 126, and 126 is greater than 77. So the mistake down here was that if I move these, you'll see those inequalities in that little problem were they were all facing the wrong direction. They were already there for you, but they were from least to greatest. So don't worry, it won't be like on the test. It'll match on the test. Okay, and then so here's the new ones. So this is all review of percents and unit rates from here on out. So first we have a percent problem. Eve is an avid reader and is looking to buy a pack of books that normally cost $80, but currently the site has a discount of 5%. What's the dollar amount of the discount? What is the sale price? What you pay after the discount? Show your work. Sorry. So remember that we would always solve percents using these proportions, right? Where we would have let me just draw it. Okay, so we would have, this is the part, and we had the whole, and then this would be the percent over 100, right? And then you can, like people will call it cross multiplying, but you are setting up, you like multiply the two that you have and divide it by what's left, or you can look for the patterns going across. So with this one, to fill it out, right, we have, erase this. So what do we have up in our problem? We have the cost is $80, and we have the discount of 5%. So 5%, right, this would just go right where the percent goes. So this would be 5. And then costs $80. Is this part of the cost or the whole cost? That's the whole cost, right? So it's the whole thing. So 80 would go down here. And so now you can figure out using a pattern. You could either do 80 times 5, 400, and then divide it by 100, which would be 4. Or another way you could do it is by thinking, you could divide, these are all different methods we used, right? You could divide this by 20. 100 divided by 20 is 5, so you could do 80 divided by 20. That would be 4. So there's different ways you could do it, but 4. Or an even easier way would be, remember we talked about the finding 10% of a number, and so if you have 80, right, 10% of that is 8, right? Because you would just take the decimal and you move it to the left. So 8 is 10%. So if you figured out that 8 was 10%, then 5% would just be half of it. So that would be 4, right? So that's another way you could do this. But the dollar amount of the discount is $4. And that means that the sale price would be $76. If you save $4 and normally costs 80, you're not paying 76. Okay, so in this one we have these two tables that we need to fill out. One of the things is, since this was a review, I was changing it up a little bit, so you can kind of ignore the colors. And there was an extra column right here. You didn't really need to fill this out or this one out, because as you will see, in order to solve, you need one of these numbers, right? You need the feet or the seconds, and these don't have the feet or the seconds. So in order to solve these, you need to find a pair that has both of the numbers. So this one has both of the numbers, feet and seconds, and this one has feet and seconds. And really what you're trying to do, remember when you're doing unit rate problems, is the best way to do this would be, well, see how this is, there's 1 foot right here? So we want seconds per foot, right? And it would, so this one's easy to figure out because 12, if you want to find the seconds for 1 foot, seconds per foot, it would be 12 divided by 4, which is 3. Another way you could figure that out is think, how do you go from 4 to 12? Using multiplication or division. Well, you could times 3. 4 times 3 is 12, right? So 1 times 3 would be 3. You could do 12 times 3, that's 36. 20 times 3 is 60. So there's that one. And this one's a little bit more tricky because 8 and 25 don't fit evenly into one another, but you can still figure out what you would multiply 8 by doing, if you did 25 divided by 8, right, that would get you 3.125. So 25 divided by 3.125. So this means that this is 8, or 8 times 3.125 would be 25. So you can solve these by multiplying times, instead of by 3 this time, it would be times 3.125. So this would literally just be 3.125. This one would be 9.375. And 5 would be 15.625. But remember, the important part with these unit rate problems is that you should have a constant number. And in this case, this first table, it was 3.125. And the second one, it is 3. So when you're done with these tables, what you should be able to do is, if you just look at the numbers that you had, right? If you just kind of go back, at the end of the time, you have all of your numbers filled out. Then you should be able to take this top number and do times 3.125 and get the bottom. 3 times 3.125, get this number. 5 times 3.125, 8 times 3.125. And you should be able to do like times 3, times 3, times 3. It should work the whole table. Otherwise, something is wrong. And again, I crossed these ones out because, right, in order to find this number, you'd have to have like a number here or a number here so you could figure it out, but we don't. So we did that. 13 says a squirrel takes 2 minutes to travel 100 yards and it drops 3 acorns from its cheeks every 50 yards. How long would it take the squirrel to travel 300 yards and how many acorns would it drop? So this is another problem that you could solve using unit rates. One example, one thing you could focus on is you want how long would it take the squirrel to travel 300 yards? That would be the first thing. And it takes 2 minutes to travel 300 yards. So you could solve these with, we did these in class doing like, let's say you had, it was 2 over 100, right? 2 minutes, sorry, I'm writing with a mouse, over 100 yards. And that would be equivalent to, we need 300 yards, right? Well, 100 times 3 is 300, so 2 times 3 would be 6, right? It's just times 6. So it would take 6 minutes. 6 minutes. And then it says it drops 3 acorns from its cheeks every 50 yards. So again, you could do 3 acorns. I'll just put an A and a Y. 3 acorns and 50 yards. And you want for 300 yards. So 50 times 6 is 300. So you do 3 times 6 would be 18 acorns. Right, so then you could say oops. It takes the squirrel 6 minutes and they would drop 18 acorns. Not very efficient if you're trying to save acorns. All right, Anthony is working on her Khan Academy assignments. As she completes each assignment, the progress bar at the bottom of the screen shows what portion of the total assignment she has finished. She has just completed assignment 24, and the progress bar shows she is 80% complete. How many total assignments did her teacher assign her to use? Okay, so this, again, we can solve using a proportion. I'm gonna solve it down here because there's a little bit extra space. So remember, we have, you want the part over the whole equals the percent over 100. So that's going to be 100 down here. And we have a percent, 80% complete, right? So that would go up here. 80 over 100 represents the 80%. And then it says, she has just completed assignment 24. So does 24 represent all of the problems or some of the problems? And another way you could, if you don't already know, another way you could help figure this out, that would help you figure this out, is this says, how many total assignments did her teacher assign her? We don't know the total. We know some of them. So 24 goes here, and we are solving for this one, whatever's down here, the whole number, 100% of the test. And another way you can think about this is, right, 24 problems was 80% of the test. So something is 100% of the test, but we don't know what that is yet. So we're solving for that. And the way that I was, the easiest way to solve this without finding patterns was, this is kind of what a lot of us ended up doing by the end is, remember, you would take the two that you have diagonally across from one another, right? 24, and you would do 24 times 100. You'd multiply them together. It gets you 2,400. And then you take the 2,400 and you divide it by what you have left, 80. So 2,400 divided by 80, which is 30. I suppose I could have done that in my head. So that means that this would be 30. X is equal to 30. So Gracie's teacher assigned her a total of 30 assignments in Khan Academy. And finally, Mrs. Penny is decorating her classroom for the holidays and wants to create hanging snowflakes in her room. She wants each snowflake to hang down from the ceiling 2 1/4 feet. How many hanging snowflakes can be made with 20 3/4 total feet of string to hang? So we have, this is how much string we have. And we want to make a bunch of smaller pieces of string, right? So we can hang things from the ceiling this long. So this is a division problem with fractions. We got to take this and divide it up. How many times can you take 20 and cut it up into 2 1/4 feet? So this would be 20 3/4 divided by 2 1/4. So remember, when you are dividing with fractions, the first thing that you want to do is just make everything an improper fraction. So this would be 20 times 4 is 80 plus 3 is 83 over 4, right? And I'm still doing division, still writing it as division. And then this, to be an improper fraction, would be 9/4. 2 times 4 plus 1. So 9/4. And then remember to multiply fractions. We multiply by the reciprocal. multiply by reciprocal. Or we remember that saying, keep, switch, flip. Right? So what we do is we keep the first one, 83 over 4. We switch from division to multiplication. And we flip the next fraction. 4/9. Remember, this is multiplying by the reciprocal because instead of dividing by 9/4, right, we're going to solve this by taking that first number and multiplying by the reciprocal, which is the fraction flipped. Okay, so that looks good. We flipped it, and then we just multiply. So you could do, remember when we multiply, you just multiply straight across. So 83 times 4 would be 332. 332. And 4 times 9 is 36. Okay, and then you could simplify this. Or if you thought of it ahead of time, you could see, hey, you have a 4 on the bottom and a 4 on the top. These could be simplified to 1 and 1. So if you did that ahead of time, you would have 83. This just simplifies to 83 over 9. If this is tricky, the canceling out to you, if you took this and simplified it just by dividing it in half and then dividing it in half again, you'd get the same fraction. And then 83 divided by 9 is, remember that, so it would be 9. 9 times 9 is 81. So 9 times 9 is 81, and this is 83. So there's 2 left over. So it would be 9 and 2 ninths, because we're on ninths. So 2 ninths is left over.
Okay.
Ta-da. So the real answer is, how many snowflakes could she make? Mrs. Penny could make 9 hanging snowflakes. All right, that is it.